I started doing the second half of section 2.1 and made a mistake. So I want to start over, but I don't have a printer handy, so I'm handwriting some problems. So the problems that are on the screen right now could have been in section P1. They just want me to reduce fractions, and I don't have any numbers to plug in for x. I don't see a little let x equal off to the side, nor am I going to set the denominator equal to 0. I only set the denominator equal to 0 when I'm asked to find the domain. So I'm just going to use the rules of exponents to simplify these, or rules of reducing fractions. Problem 18, to reduce this fraction, I'm just going to divide 25 divided by 5 and get 5. 15 divided by 5 and get 3. And the x's, I'm going to subtract the exponents, because the bigger exponent's in the numerator, I'm going to leave the x in the numerator. So for my answer for question 18 in section 2.1, I can say it's going to be 5x to the first power over 3. Anytime you have a variable in the numerator of a fraction, if that fraction has only multiplication in the numerator, you are allowed to drag that variable off to the right of the fraction. Both of those are equally correct. I'll do the same for 20. 14 over 21 I'm going to reduce by 7. I'm going to go 14 divided by 7 is 2. 21 divided by 7 is 3. And get the fraction 2/3. Remembering what we did back in sections P1 and P2, for this kind of fraction, when I have variables, I'm going to leave the variable where the bigger exponent is, subtract big exponent minus small exponent, leave the variable where the big exponent is. For the x, the larger variable is in the numerator, so I'm going to take the exponent of 3 and 1, subtract them, leave the x in the numerator to avoid negative exponents. For the t's, the bigger exponent on the t is in the denominator. I'm going to subtract the big exponent 6 minus the small exponent 2 and leave the t in the denominator. For an answer for number 20, I can write 2x squared over 3t to the 4th. And although I'm allowed to drag that x squared and make it off to the right of the fraction, since there's a number in the denominator, that seems odd to do. If you forgot how to reduce the x cubed over x, or if you forgot how to reduce the t squared over t to the 6th, I can revert to changing the exponents into repeated multiplication. The x cubed over x, I can see that I'm left with an x squared in the numerator, because if I cancel the x in the denominator with one of the 3x is in the numerator, I'm left with 2x's or x squared in the numerator. Similarly, if I wrote 2t's in the numerator for the t to the 6th squared and 6t's in the denominator for the t to the 6th, I can see that I'm left, when I cancel, with 4t's in the denominator. Problem 20 isn't reducing with negative exponents, just a negative coefficient, and a positive divided by a negative is a negative. The first thing I need to do in 20 is reduce the fraction negative 18 over 24, and it reduces to negative 3/4. My calculator instinctively is programmed to write the negative to the left of the fraction. I'm instinctively inclined to put the negative in the numerator of the fraction. They're both correct, to work with the x, to work with the negative sign. It's not a negative exponent. I don't need to invert to make the fraction flipped. It's just a negative number. Now I'm going to work on the x's. For the x's, I'm going to go big exponent in the denominator, so the x is going to wind up in the denominator. I'm going to subtract the exponent in the denominator of 2 minus the exponent in the numerator, and that's going to give me an x to the first power. When I go to write either version of my answer, either the one with the negative out front or the negative in the numerator, I'm going to have a 4x in the denominator. The y's are both y squared, so they're going to cancel. The z, The exponent in the z's numerator is 3 and the denominator is 1, so the z is going to wind up in the numerator. I do big minus small exponent, leave the letter where the big exponent is. And both of these are correct answers for 22. I don't know that one's better than another. I could even drag the negative and move it into the denominator next to the 4, but that would just be odd. I wouldn't do that unless I really had a reason. So you should be able to do 17, 19, and 21. I also did problem 24 when I made a mistake. I'll talk through problem 24. The answer is 1/3. So I'm asked to reduce this fraction 12 over 36, 12 times y minus 7 over 36 times y minus 7. I kind of thought of this as two separate problems. The first thing I did is reduce the fraction 12 over 36, which reduces to 1/3. I definitely know I'm going to get a 3 in the denominator of a fraction. When a fraction reduces and it has a 1 in the numerator, sometimes I don't write that 1 in right away. If there's nothing left to put in the numerator, I'm going to leave a 1 behind. But if there's something when I'm reducing other than 1 that goes in the numerator, I'd probably suppress that 1. So I started off when I did this, I said, well, I know I'm going to need a 3 in the denominator because that first fraction reduces to 1/3. Then the y minus 7 over y minus 7, well, those are identical. Anything divided by itself cancels to 1. So what I did is I canceled the y minus 7s and wrote 1 behind. What I left behind is a 1 from the 12, a 1 from the y minus 7 in the numerator. So my numerator, both have 1s. I can multiply those. My denominator, the 36, turned into a 3, and these are an implied times between these. The denominator's y minus 7 turned into a 1. So what I really have left is 1 times 1 over 3 times 1. I multiply the 1s in the numerator, the 1s in the 3 and the 1 in the denominator, and I get that 1/3. When I started talking about 26, this is where I flubbed up. And it was a bad flub because this is where students make mistakes. They start thinking that when you can reduce the same way, regardless of if problems are straight multiplication or if problems have addition or subtraction between the terms. And I pulled out a sheet of paper and I made up a problem to try to illustrate something. If I look at a problem that has straight multiplication without letters, something like this, 2 times 4 over 2 times 1. I could do this without reducing. I could say that this is 8, because 2 times 4 is 8, over 2 because 2 times 1 is 2, and 8 over 2 is 4. That's a completely acceptable way to reduce that problem. It's a correct answer, absolutely. If I was clever, I know that if there's straight multiplication across the numerator of a fraction and straight multiplication across the denominator of the fraction, that I can reduce before I multiply. And I could have reduced this. I could have made that 2 and that 2 into a 1 by reducing them. That would leave me with 1 times 4 over 1 times 1. That's going to be 4 over 1, and that's just 4. When there's straight multiplication in both the numerator and the denominator of a fraction, you can reduce any denominator with any numerator without really any fear. However, if I switch this problem up and made it 2 plus 4, change that times sign to a plus over 2 plus 1, I can definitely do this just the traditional way. Add the 2 and the 4 in the numerator and get a 6. Add the 2 and the 1 in the denominator and get a 3. 6 divided by 3 is 2. That's definitely the answer. If I pulled out my calculator and did 2 plus 4 divided by 2 plus 1, my calculator would give me that same number too. Let's show you what happens if I try to cancel. If there's addition between numbers or subtraction between numbers or numbers and letters, I can't reduce like I just reduced. Let me try to reduce this the same way that I did the above problem. Go 2 divided by 2 is 1. 2 divided by 2 is 1. This would leave me with 1 plus 4 over 1 plus 1. That's 5 over 2. 5 over 2 is not 2. 4 over 2 is 2. This is actually 2.5. This gives me an error and a wrong answer, which is really important. It turns out that if there's a plus or a minus between numbers, or a plus or a minus between numbers and letters, you can't reduce unless they're identical and they're reduced to 1. In problem 24, there was a minus sign between a number, the letter y, and the number 7, but they're identical. That's the only time I'm allowed to reduce, if there's pluses or minuses between numbers and letters, if they're identical and they're reduced to 1. Had this problem said something like y plus, let me just do this, y plus 4 over y plus 1, I couldn't cancel the y's, just like I can't cancel the 2's here. This one right here will not reduce. This one does not reduce. So the big important part of the next group of problems in most of section 2.2 is you can only reduce when there's adding or subtracting between numbers and letters if the numerator and the denominator are identical and they reduce to 1. So something like this, if I had like x minus or x plus 6 over x plus 6, that reduces and equals 1s. But if they're not identical and you try to individually reduce like you can when you have straight multiplication, you're not guaranteed to get that same answer. Here, straight multiplication across the numerator and the denominator of a fraction, you can reduce either number in the numerator with either in the denominator, but addition between terms or subtraction between terms, you can only reduce if they're identical. This would be the case. If I said reduce 2 plus 4 over 2 plus 4, those are identical, those reduce to 1, because this is really 6 in the numerator, 6 in the denominator, that reduces to 1. Pluses or minuses between terms only can reduce if they reduce to 1. That's hugely important. So in problem 26, I look at the fractions, the p minus 3 in the numerator and the p minus 3 in the denominator. Those are identical. Those can cancel and they reduce to 1 when they cancel. The p plus 4 and p minus 6 aren't identical, which means they can't reduce because there's addition between the p and the 4, or the subtraction between the p and the minus 6. So what I'm going to have when I reduce is 1 times p plus 4 over p minus 6 times 1. Anything times 1 is itself. So this numerator, 1 times p plus 4, is just p plus 4. I don't need the parentheses. P plus 4 in a parentheses with nothing but a 1 in front of it is equal to p plus 4. And in the denominator, p minus 6 times 1 is equal to p minus 6. I don't need the parentheses. Here, this is the answer. I can't cancel the p's. I can't cancel the 4 nor in the 6. So it would be wrong. You can't cancel the p's. And you can't reduce the 4 and the negative 6. You can only reduce like that if there were time signs. If this said reduce 4p over negative 6p and there weren't the addition or subtraction signs between, then this you can reduce. This one I could cancel the p's and reduce the fraction to 2 over negative 3, which looks so odd, but I'll live with it. But addition between terms, it's super limited in when you can reduce. Notice up here, there was straight multiplication in the numerator, and I had identical y minus 7s I can cancel. Straight multiplication in the numerator, when the factors are identical, they can cancel. When the factors aren't identical, they can't cancel. In 28, I can cancel the x minus 1s. They're identical top and bottom. The numerator is completely factored. The denominator is completely factored. I can cancel the x plus 3s. They're identical. When I cancel things, they turn into 1s. I usually don't write the 1s. After I cancel, the numerator has a 15 left and a couple of 1s that I don't need to write. The denominator has an x plus 2 left, and because I've gotten rid of all the factoring, I don't need the parentheses anymore. The rest of the problems in the section, I'm going to need to factor before I can cancel. A 12 can't cancel with a 24b plus 6. In problem 30, a 24b plus 6, if you have a plus sign between a number and a letter, it could only reduce with an exact copy. What I'm going to do is try to turn number 30 into something that looks like 24, at least as close as I can. I'm going to get some factoring done. And the only factoring that can be done in number 30 is 1 parentheses common factor factoring. The denominator has a GCF of 6. I'm going to write that GCF of 6 to the left of a parentheses in the denominator. Now I'm freeing up the number 6 from the addition. I could cancel it with the 12. Just like in this problem, I was able to cancel the 12 and the 36 because they're just all in a part of a string of multiplication. I'm allowed now to cancel the 12 with the 6, but let me finish up the factoring. I'm going to take the 24b and divide it by 6 and be left with 4b. And after the plus sign, the 6 divided by 6 and be left with a 1. Now I'm going to cancel the 12 and the 6. I'm going to go 12 divided by 6 is 2. 6 divided by 6 is 1. I have 2 in the numerator and 1 times 4b plus 1 in the denominator, and anything times 1 is itself. So I'm just going to write the denominator as 4b plus 1. In the denominator, that 4b plus 1 can only cancel with another 4b plus 1. Once there's straight addition and no multiplication off to the left, you can only cancel identicals, and a 4b plus 1 can only cancel with a 4b plus 1. Your problem 10 should work real similarly. In fact, all our problems are kind of paired up on purpose to work together. For 31 through 38, same deal. I can't cancel the way the problems are written. If there's adding or subtracting in the numerator and the denominator are both, you could only cancel if the numerator and the denominator are identical, or if you have factoring and the factorings give you identical factors. So I'm going to 1 parentheses factor the numerator in 32. There's a common factor of a 5. When I pull out the common factor of 5, that 5 I divide by 5 and get 1, and I leave my x. The 15 I divide by 5 and I get a 3. The denominator is a square with a minus, so the denominator, I'm going to get 2 identical parentheses. One of the parentheses is going to have a plus, the other is going to have a minus, and I'm going to sight factor. The x, I'm going to divide its exponent by 2 and get x to the first. I'm going to put that before the signs. The 9, I'm going to square root it and get a 3 and put that after the signs. My parentheses are going to have an x plus 3 and an x minus 3. Now that everything's factored, identical factors can cancel. So I'm going to cancel in the numerator the x plus 3 with the x plus 3 in the denominator. I'm going to be left with a 5 in the numerator. And because I've canceled all the factoring out of the denominator, the x minus 3 doesn't need to be in a parentheses anymore. The x minus 3 that's in the denominator could only cancel with another x minus 3. So that's all I can do for 32. 34 is similar in that I'm going to common factor, GCF factor the numerator. The numerator of 5x minus 5 in 34 is a common factor of 5. I'm not factoring out a negative because the first term is positive. I'm going to divide the 5 in front of the x by 5 and get a 1 and leave the x. After the minus sign, I'll divide the 5 by 5 and get a 1. I'm going to 2 parentheses sight factor the denominator because there's not a number in front of the square term. I'm going to look for numbers that multiply to positive 6. They need to be double negative, and they need to add to negative 7. And that's going to be negative 1 and negative 6. If I multiply negative 1 and negative 6, they're double negative. They multiply to positive 6. If I add negative 1 and negative 6, they add to negative 7. So as I go through this chapter, I'm not going to explain the factoring near as much as I would have in the last chapter, specifically because we tested on it, and I hope you can factor without me explaining every factoring, because it takes a long time if I give all the detail here that I did when we were just learning factoring. Now that I have it factored, I'm going to cancel the identical x minus 1s. The numerator is going to be left with a 5. The denominator has an x minus 6 that doesn't need to be in a parentheses anymore because I got rid of all the factoring. For 36, I'm going to sight factor the numerator and sight factor the denominator. When I go to do the numerator, I need numbers that multiply to negative 6. One will be plus, the other will be minus. They add, subtract to the 1 that's in front of the b term, and that's going to be 3 and negative 2, because 3 times negative 2 multiplies to be negative 6, and 3 plus negative 2 is the same as 3 minus 2, which is 1. So in my numerator, I'm going to get a b plus 3 and a b minus 2. The denominator is going to be similar. When I go to factor the denominator, I'm looking for numbers that multiply to negative 8 and add, subtract to 2. And that's going to be 4 and negative 2, because 4 times negative 2 is negative 8, and 4 plus negative 2 is the same as 4 minus 2, which is going to be 2. So when I sight factor the denominator, I'm going to get a b plus 4 and a b minus 2. The b minus 2's are identical. That's the only time I can cancel when I have addition or subtraction between variables and constants. I can only cancel if they're identical. If they're not identical, I can't cancel at all unless it was straight multiplication. Since the b and the 3 have a plus sign between them, I can only cancel with another b plus 3. So my answer for problem 36 is going to be b plus 3 over b plus 4. Let's do 37 together. I'll skip 38 because we have this hard factoring to deal with. So in 37, it's factoring by grouping in the numerator. So as I'm working on problem 37, I need to factor both the numerator and the denominator. And I'm going to emphasize that numerator for 37 is 2y squared plus 1y minus 6. You should pause the video and try to do this problem rather than watch me do it. It's much better if you do it yourself. But I'm going to do it, and I'm going to start off by multiplying the 2 and the negative 6 and getting negative 12. I'm going to search for numbers that multiply to negative 12 and that add but really subtract to this 1. The numbers are going to be 4 and negative 3, because 4 times negative 3 is negative 12. 4 plus negative 3 is the same as 4 minus 3, which is the 1. So the 1y, I can write it as 4y minus 3y when I group, or I can write it as negative 3y plus 4y, and I prefer, if I have a positive and a negative, to write the positive second. So I'm going to factor this by grouping. I'm going to make it 2y squared minus 3y plus 4y minus 6. Introduce my two parentheses. First parentheses is a common factor of a y, and I'll be left with a 2y minus 3. After the plus sign, I'm going to factor out a 2 and be left with a 2y minus 3. So that numerator is going to have two factors. One of the factors is going to be 2y minus 3. The other is going to be a y plus 2. So when I'm doing problem 37, I'm going to have two factors in the numerator. One's going to be a 2y minus 3. The other's going to be a y plus 2. I'll move on to the denominator. The denominator of y squared plus y minus 2 I could sight factor. I'm going to make two parentheses that lead off with a y. And the numbers that I put in those parentheses, they need to multiply to negative 2. They need to add but really subtract to positive 1. And that's going to be 2 and negative 1, because 2 times negative 1 is negative 2. 2 plus negative 1 is the same as 2 minus 1, which is 1. So that denominator is going to factor into a y plus 2 and a y minus 1. I'm going to put those two parentheses in my work. And then I see the identical factors that can cancel. So I'm going to cancel my y plus 2's. I'm ready to write an answer. I don't need the parentheses anymore. For 37, the numerator answer is going to be 2y minus 3. The denominator is going to be y minus 1. I have 4 problems left. I don't want to put something that's 8 minutes or 10 minutes into a new video, so I'm just going to extend this, but it's kind of a new concept. So 39 through 46 has a trick that most of these either reduce to negative 1 or they reduce to something with a negative. In each of the problems between 39 and 46, I'm going to follow these steps. I'm going to say, if needed, first, line up the numbers and the letters. I'm going to say, write so that the letters, could say variable and use a better word, are lined up. I can't reduce problem 40 the way it's written because the numerator and the denominator aren't identical. A y minus 3 doesn't cancel with a 3 minus y. A y minus 3 only cancels with a y minus 3. So I'm going to write the denominator with the y first and the 3 second. I'll keep the negative sign in front of the y. I get a plus sign in front of the 3 because it's positive. That was needed. I just lined up the letters. Second, I'm going to factor out a negative 1 or a negative GCF where needed. So some of these problems have GCFs, some of them don't have GCFs, but most of them lead somewhere with a negative, and I need to get that factored out. In problem 40, the numerator doesn't lead with a negative. It doesn't have a GCF. I don't need to worry about it. But in the numerator, the denominator leads off with a negative. I need to factor out a negative 1. It leads with a negative, but it doesn't have a GCF, so I'm just going to factor out a negative 1. I'm going to change the negative y to positive y, the positive 3 to negative 3. And now I'm going to move into canceling. So I lined up when it was, because it was needed. I factored, and now I'm going to cancel. The y minus 3's, they cancel to become 1's. I can't write a fraction without a numerator, so I'm going to leave the 1 behind that fraction reduces into. And now I'm going to have the fraction 1 over negative 1, and that reduces to negative 1. So that whole fraction reduces to negative 1. That's why the instructions say reduce the expression, which means it doesn't have an equal sign, involving a ratio, which means fraction of negative 1. This is a fraction that reduced to negative 1. For problem 32, the letters are lined up, so I don't need to do that step of lining up the letters. So I'm going to go down to the second step. I'm going to either factor out a negative 1 or a GCF. There isn't a GCF in the numerator, but the first term is negative, so I'm going to factor out a negative 1. When I factor out a negative 1, I flip the signs. The negative 3x turns to positive 3x. The negative 7 turns to positive 7. The denominator doesn't lead with a negative. It doesn't have a GCF. I'm not going to do anything with it. Now I'm going to cancel because I have identicals. The 3x plus 7s are identicals. they can cancel. They technically turn into 1s. Really what I have when I cancel in the numerator is -1 times 1, and in the denominator is 1. I don't need to write a fraction when it has a 1 in the denominator. It'll just equal its numerator, and -1 times +1 is just -1. So my answer to 42 is also -1. When I move down to 44, I need to line up the variables. In the numerator, it's not written in the nice order because the -2x should be written, the letter should be written first. So I'm going to rewrite the numerator. And now I have some GCFs to deal with. Both the numerator and the denominator have a GCF that can be factored, so I'm going to factor it out. In the numerator, the first term is negative. I'm going to factor out a negative. And there's a common factor of 2. I'm also going to factor out a 2. I'm going to flip the sign. So the first term is going to go from negative to positive. I'm going to divide out the 2 and just be left with an x out front. This plus sign in the numerator, because I'm factoring out a negative, is going to flip to negative. I'll take the 10 and divide it by 2 and get a 5. So the numerator, that has the negative GCF factoring. The denominator, I'm going to factor out a 3. I'm not going to factor out a negative from the denominator because the first term is positive. It has a GCF, so I need to factor, don't need to factor out a negative. Inside the parentheses, this 3 I'll divide by 3. I'll leave with a 1x. I'll keep the sign because I didn't factor out a negative. That 15 divided by 3 will give me a 5. Now the x minus 5's top and bottom are identical. I can cancel them and get -2/3. My instructions are going to fail me a little bit on problem 46, but I still think you could get it probably even without my explanation. So the best I can, I'm going to work through 46. This 44 didn't turn to -1, but it turned to a negative anyways. All these problems between 39 and 46, oh, they're going to cancel, and the answer is going to be negative at least, if not -1. In 46, I'm going to line up the letters the best I can. I can't really put the letters with the powers lined up perfectly because I have different powers in the numerator and the denominator. So that's kind of my first step, lining up the letters. And now there isn't a GCF in the numerator, there isn't a GCF in the denominator, so I'm not factoring out a GCF, but the numerator leads off with a negative, so I'm going to factor out a -1 from the numerator. When I factor out a -1 from the numerator, the negative x squared is going to turn to positive x squared. The positive 36 is going to turn to -36. My instructions kind of fail me because it doesn't tell me that I need to factor that x squared minus 36, but hopefully you'd realize that that's important. And to factor that x squared minus 36 that's in the parentheses, to make that into 2 parentheses so I can get some fact canceling done, that's a square with a minus. To factor that x squared minus 36, I need to divide the exponent of the x by 2, and I need to square root the 36. For the x, when I divide it exponent by 2, I'll get an x. And the 36, when I square root it, I'll get 6. So when I'm factoring squares with minuses or differences of squares, the contents of the parentheses, other than one having a plus sign, the other having a minus sign, are the same. And now I'm going to cancel the x minus 6. I've canceled the entire denominator, so I don't need to write a fraction. My answer won't be a fraction. The numerator's factored. That's actually a better answer. It would be better in problem 46 to leave my answer -1 times x plus 6. It would be equally okay if I just wrote a negative sign next to the x plus 6. Not as good, but I can flip the parentheses, get rid of the parentheses, and write the opposite of the inside of the parentheses if I care to. All 3 of those would be correct answers. I guess these are the better answers, and this is just kind of an okay answer. So that's everything for section 2.1. Quite honestly, I could have attached section 2.2 and made it into a gigantic section, because the skills for reducing that we've done in section 2.1 are really the only skills we need in 2.2. So there is not going to be a lot new to learn in section 2.2. It should be a nice section, other than there's a ton of factoring in it.